Okay, so we are continuing with limits, and really we talked about some of these last time. We're going to deal with limits from the left and limits from the right, which we've already gone over a little bit. So if you look at the first part here, limit of f of x as x approaches c with a little negative sign. We know that's from the left, right?
Yes.
Thanks. So then the next part here is x approaches c with a plus sign. What does that mean? So just the limit of f of x as x approaches c, so not from the left or the right, it exists if the left equals the right. The limit from the left and the limit from the right are the same. That's the only way it can exist. It's different, you tell me does not exist. Which again, we talked about that last class, right? Alright, so let's do an example here. We've got a business that opened in 2007. Total number of stores, 15. So we're going to write this as a limit situation, and we're letting 2007 equal the same as t equals 0. So if we draw a little picture, so this is 0 for our time. This is our time. This is number of stores. We know that when t equaled 0, we were up here at 15 stores, right? I'm just making the assumption that the number of their stores grew. I don't really know that. We're just drawing the graph that way. So let's think about our limit from both sides here. So the limit of the function as x approaches 0 from the right. Well, we're approaching 0 from the right. 15, right? If it was infinity, it'd be infinity. But what about the limit of our function as we approach 0 from the left? Is there anywhere on the left to even come from? No. Did any of these stores even exist before then? No. We don't know anything about before 2007. So from the left does not exist. So the question here, does it make sense to approach 0 from both sides? What do you think? No, we don't have information about from the left. Okay. Okay, so now let's look at this delivery truck. This time they gave us the graph over here, so that's nice. It's much prettier than my graph. So they charge $18 for the first pound, $2 for each additional pound. We've got x being how much our parcel weighs, and f of x is the total shipping cost. All right, so we're looking at the limit as x approaches 2. So look on your graph over here. Here's 2, right? And draw a little imaginary line. What do you think? Does this section of the graph right here have anything to do with the limit as x approaches 2? No, which means this part of the equation has nothing to do with it. So we don't need that. We're just going to focus in on the stuff around 2. So let's write our limit statements. So the limit of f of x as x approaches 2 from the right. You've got the graph, which is easy to see from the right. You can also do it from the equation. Do you guys see how this x is to the right of 2 because it's things bigger than 2? Does that make sense? And this x is left of 2 because it's things less than 2. Okay, so So that's how you pick which equation if you don't have the graph. But from the graph, it's very simple to look at. From the right, what is our limit?
22.
22. Okay. And then the limit of our function as x approaches 2 from the left. So you have to hop down here. We're coming in. Remember your little guy's walking on the graph. What's he running into? 20. Are they the same? So you can say therefore, which is just the 3 dots. The limit of f of x as x approaches 2 does not exist. Okay. Good so far? So far, yeah, baby steps. Don't get scared because it says piecewise. You don't have to graph piecewise. I know you guys do a lot of you hate the idea of graphing the piecewise function. Yeah, we don't have to make a picture for this. We can do this from the left and from the right with the equations. All right, so we are finding both the left and right hand limits. So the limit as x approaches 3, let's go from the right first. So I'm not going to write f of x. I'm going to pick which of these equations is actually from the right.
The top.
Yeah, does that make sense? Because you want x to be bigger than 3 to be from the right, so this is from the right. Are you guys okay with that? Yeah, okay. So instead of writing f of x, I'm just going to write x squared. So then I can just plug in my value. So that would be 3 squared, and I get 9 as my limit from the right. Okay. So when I go to do the limit from the left, so the limit as x approaches 3 from the left, 6x minus 4 equals, you can just plug in your 3, so 6 times 3 minus 4. What did we get? Sorry. 14, right? Either way, it's not 9, so okay. So we can say, therefore, the limit of our function as x approaches 3 does not exist. Okay. You guys try letter B for me. Guys, try B, C, and D. They're all, I mean, it's all the same idea. So let's see what all of those. Your stats on me. I'm going to put B up here, make sure we're good with that. Is everybody okay with B getting 0 for your limits? The left and the right were 0? Okay. Should we talk about C? Yeah. Okay. All right, so you're given over here that if x doesn't equal 3, I've got this fraction, and if it equals 3, I know my y value is 8. Think back to when we did them graphically. Like, let's say my graph looked like that, and then I had that, just that dot up there. Did the dot mean anything when I was finding the limit? No, we didn't care about the dot at all. We cared about what we're approaching from each side. So which of these gives me just a dot? Yeah, but where x equals 3, okay? We don't care about that. You do not need this 8 if x equals 3. Because that only gives me the point, and I don't want the point. So, you use this fraction for both things, from the left and from the right. So if I do limit as x approaches 3 from the right, I'm just going to go ahead and factor it right away. So that cancels out. I'm looking at 3 plus 3, which is 6. Is from the left going to be anything different? No, because you're still plugging in to the exact same equation. Okay, so therefore the limit as x approaches 3 of our function is 6. I clearly didn't graph what this equation actually is. That was just to give you an idea. Okay. Are we okay with that? All right. So letter D. It's the same idea, right? Which part do I not want? Yeah, I don't want that because that's just the point. So approaches -2 from the right. I'm going to factor it. It'd be x plus 2 times x minus 3, or x plus 2. Are you getting -5? Okay. It's going to be the same thing. So therefore the limit of f of x as x approaches -2. is negative 5. Yes.
For the factor,
Like this, like do I have to do this?
yeah.
Yes, because if not, when you plug negative 2 in, you get a 0 in the denominator. So that's why I factored to get rid of it. Give me a minute, make sure everybody's with me. Flip your notes over when you're ready. You don't have a lot left. It's a quick lesson today.
What's that next?
Do you have a test?
What do we do? If we other test is like, it's optional.
Yes, so like the retake. It'll be the end of the quarter. So, yeah. All right, so when we are doing asymptotes, first you guys know what an asymptote looks like, right? There, and then usually you have a graph doing something like that, right? Okay. You still have to check the left and right hand limit. So you must check. And the answer will be positive or negative infinity, comma does not exist. You guys remember these from last year?
Yeah.
Yeah. All right, one person. That's pretty good. I'm not claiming that. All right, let's do A together. So this one, the graph is given to you. I'm telling you to find the limit as x approaches 2.
You guys just get random breaks there with that? Or around the hallway?
Not a thing.
You're the only teacher who doesn't do it.
I'm the only one. I'm the only mean one. Well, not one staying mean. So. All right, so let's look at this. We have to do the limit of 3 over x minus 2 as x approaches 2 from the right. And then we have to do the same thing, 3 over x minus 2 as x approaches 2 from the left. Okay. First one, you're given the graph, which is helpful. So let's start at 2 from the right. Do you guys see how 2 on the graph over here is where the asymptote is? So if I put my little guy on here to start walking towards 2. He's walking, he's walking, he's walking, he's walking, he's walking, he keeps walking. Oh my goodness, where is he walking to? It's up as high as he could walk. Infinity. Okay. Is infinity a defined value? No. So the limit as x approaches 2 from the right is infinity, comma, does not exist because it's not a specific number. Okay. So then if we go 2 from the left, so I put him on my graph, and he starts walking. Where does he walk to? Negative infinity, comma, does not exist. Okay. So the two guys I drew on the graph, are they going to run into each other? No. So what would you tell me about the overall limit just as x approaches 2? Does not exist, right? They're not running into each other. It's just does not exist. Yeah. I'm going to show you how to do it without a calculator. Because it's not very hard. Promise. I won't give you super complicated ones to do without a calculator. It would be ones like this. Okay. Oh, no. So you can make the picture of the graph. Because really the only way to do these is with thinking about what the graph looks like. Okay, so we'll do that together. All right. So is everybody okay with A?
Words with equals do not exist.
Yeah, because they didn't match, right?
Oh yeah, true.
If they were both going the same direction, like if they happen to both go to infinity does not exist, then infinity does not exist would be your answer. But when they're opposite directions, then it's just does not exist. Okay, so let's look at B. Does everybody see how we can't just plug the 1 in?
Yeah.
Okay, and nothing's going to factor and cancel it out, which means this is a graph that has an asymptote at x equals 1. So there's 1. I'm going to draw in my asymptote here.
Wait, let's just say there's x minus 2, then you can just plug it in.
Yes.
Okay.
Yep, good. All right. With these graphs, hopefully you remember from pre-calc and even algebra 2 that if you have an asymptote over here, your options for where the graph can go is here, here, could be like here, here, or like here. That's a terrible error. Or here, right? Like you've got, there's like 2 pieces in each graph, right? Okay. We just need to figure out where those pieces are going. So I am looking at this. It's bottom heavy, which all of these are going to be bottom heavy. And all that means is that I also have an asymptote right on the x-axis, which just helps divide up my quadrants so that I can see where the graph is going. And I want to know what's happening as x approaches 1 from the right. Well, give me a number that's to the right of 1. 2. So let's see if I plug in a 2. So plug in 2. I get negative 3 over 2 minus 1, which is negative 3 over 1, which is negative 3, right? You with me? So that means the point 2, negative 3 is on my graph. Well, 2, negative 3 is somewhere down here. That's all I need to find to know where this graph is going. That means I've definitely got some of it down here. Do you guys see how that 1 point told me enough? Okay. Because it's not going to cross the vertical asymptote. It could cross the horizontal, but what I'm giving you simple ones, that's not going to happen. So if it's in this quadrant, you know the graph is doing this. I could find 1 on the other side of it, but I only asked you about the limit as x approaches 1 from the right. So, what are you going to tell me? What does it equal? There you go. Do C together. Okay, so I'm going to sketch my graph. What do you think, guys? Where are my asymptotes? 0 for both, right? Vertical and horizontal. Everybody understand that? Okay. I have an asymptote there. An asymptote sort of there.
Why is it horizontal? That's 0.
Anytime it's bottom heavy, you always have the horizontal. Remember, like bottom heavy, top heavy equal?
Okay.
Okay.
When's it slant?
If it's top,
Okay.
you're not going to do it like this.
Okay.
If there's a slant asymptote, you have it calculated. Okay. All right. So I have to now think about the limit of 1 over x squared as x approaches 0 from the right, and the limit of 1 over x squared as x approaches 0 from the left. Okay, because this asks me about just the overall limit. So let's do from the right first. Give me a point that is to the right of 0. 1. What do you get when you plug in 1? 1. So the point 1, 1 is somewhere up here, right? Is that enough to give me part of this graph? It is. Yeah. Is everybody, are you drawing that? Okay. All we're looking for is general shape here. I'm not looking for some perfectly graphed graph. All right, so what do you think as x approaches 0 from the right, what would you tell me the limit is? Good. Infinity, comma does not exist. All right, that's not enough for this problem though. We also have to do from the left. So give me a number left of 0. -1. When I plug in -1, what do I get? 1. So it's up here. Again, that's enough to show me that, okay, my graph must be up in this quadrant or something like that. So what would you tell me about the limit as x approaches 0 from the left? Where's it going? Because I come from the left, where am I going? Up, right? So infinity, comma, does not exist. So then the actual question was the limit as x approaches 0 of 1 over x squared. So we looked at the left and the right. Did they match or not? Okay, so what do you think the answer is? Infinity does not exist. They're still not really going to run into each other, but they're both going the same direction. Okay, so that is... All right, you guys try D. Make a little picture for me. And you'll have to do from the right and from the left. guys, don't forget to actually do the limit statement. Like, I'm not just writing this because I think it's really fun to write this. This is a part of your answer, okay?
One more minute here, then we'll look at it.
Honestly, like, I'm kind of that way. I honestly think you really have that. Actually, it's this whole the whole body. And also my mythology, so sorry. I mean, honestly,
All right, last one here, guys. So on our graph, we know we have an asymptote at 5. And guys, are you okay with there also being an asymptote at 0? Because that exponent on the degree on your denominator is bigger. Then what you're doing is plugging in values. So like to the right of 5, I might plug in a 6. When I do that, I get -3. That's not telling me the limit, that's just giving me this point down here so that I can sketch the graph. Okay, so you would tell me the limit there is -infinity. That's not a limit. 5 from the left, you're picking a value left of 5, so maybe 4. When you plug 4 in, you also get -3. So the graph's doing something like that. The limit there is also -infinity, does not exist. They're going the same direction, so your overall limit is -infinity. Okay? Questions? Yes. So ones with asymptotes, yes. So like on the warm-up, like the if it's something like this where you can just plug it in and you don't have an asymptote, you don't have a hole, you know, no issues with zeroing your denominator, plug it in, that's it. You don't have to do it from left to right. But when it's an asymptote, it's okay.
All right, guys. Any other questions?
How those packets coming?
I was able to make 2 classes.